Alright, so this is my question. It is from 1999, and it's question number 1 of the free response for that year. So, Lydia and Bob were searching the internet to find information on air travel in the United States. They found data on the number of commercial aircraft flying in the United States during the years 1990 to 1998. The dates were recorded as years since 1990. Thus, the year 1990 was recorded as year 0. They fit a least squares regression line to the data. The graph of the residuals and part of the computer output for the regression are given below. So part A of this question asks, is a line an appropriate model to use for these data? What information tells you this? So this is really easy. All you have to do to tell if a line is an appropriate model to use is you look at the residual plot, and if there's some sort of pattern, you know right away that a line is not an appropriate model to use. But as you can see, there's no clear pattern indicated by the residual plot. So we can say that yes, a line is an appropriate model to use. And you can also use the t-test to confirm this, but that is not necessary to get an essentially correct on part A. So part B asks, what is the value of the slope of the least squares regression line? Interpret the slope in the context of the situation. This is also pretty simple. So all you have to do is be able to interpret this table right here. So the slope is 233.517. So that's right here. You just have to know that that number is the slope. And so that's 233.517 aircraft per year. Or you can round that to 234 aircraft per year. And then make sure to interpret the slope in the context of the situation. So basically, you just have to say, you have to write out that on average, the number of commercial aircraft flying in the U.S. increased by approximately 233.517 or 234 each year. So you have to draw the distinction between the model and the data. And as long as you incorporate the idea of estimation using words like average or predicted or approximately, then it's still considered essentially correct. So part C is similar, but this time they're asking you for the intercept of the least squares regression line. So you look right here, and this is the intercept. So don't forget to interpret that in the context of the situation. So you would have to write out, after saying the intercept is 2,939.93 aircraft, you would have to write the predicted number of commercial aircraft that were flying in 1990, since X is 0 corresponds to the year 1990, of course, was 2,939.93. And again, it's fine if you round this, so you could round it to 2,940. And the same requirements for part B and C. You have to draw the distinction between the model and the data, and you have to incorporate the idea of estimation. So that means using words like on average, predicted, approximately. And then part D here asks, what is the predicted number of commercial aircraft flying in 1992? So this is a little bit trickier. So you have to write out the linear model. But basically all you do is you use those values that you got from part B and part C. So what we're going to do is just write out the linear model here. So, and the little hat above the Y indicates that we're predicting Y from X. So write that out. Y with the little hat on top of it equals, and then 2,939.93 plus 233.517 times 2, because 1992, remember X would equal 2 here since it's 2 years after 1990. And then you plug that into your calculator, and you will get 3,406.964 aircraft. There you go. And I apologize for my handwriting. All right. So for that, it is considered essentially correct, or it can be considered essentially correct if incorrect numbers from previous parts are correctly substituted. So for instance, if you said the wrong thing for part B or for part C, you know, if you gave the wrong slope, or maybe you mixed up the slope and the intercept on this table, of course you'll get part B and part C wrong. But if you use those numbers and you put them in the right way for part D, if you, if you use them, you know how to do part D basically, but you just use the wrong numbers, then you will still get part D essentially correct. And then the last part of this question, part E, what was the actual number of commercial aircraft flying in 1992? So, for this part, basically you need to know that residual is the actual minus the predicted. So if we look up here at 1992, if we look on this residual plot, so 1992, we go up here, the point is at 40. So that means that the actual minus the predicted is 40. So that means that the actual equals 3,406.964 plus that 40. So that equals 3,446.964 aircraft. So there's your answer, and since the actual number flying has to be an integer, it must have been 3,447, so you can round that if you want to, but it's not necessary to get an essentially correct on that question, so you can leave it like that. And that is all for this question. So I didn't write out the answers for parts A, B, and C, but just remember to give the answer and don't forget to interpret. If it asks you to interpret, you need to interpret. Even if it doesn't ask you, it's probably a good idea to interpret. And then here are the guidelines for the responses. So this question is scored. You can get a 1, a 2, a 3, or a 4. Of course, you're aiming for a 4, which is a complete response. You get an essentially correct response for all 5 parts. You can get a number 3, which is a substantial response. That means that you got an essentially correct on 4 of the 5 parts. So even if you don't get an essentially correct on just one of them, that'll drop you down to a 3. Or you get an essentially correct on responses, or on A, D, and E, and partially correct responses on both B and C. And then you can get a 2, a developing response, by getting essentially correct on 3 of the 5 parts, or partially correct responses on both B and C, and essentially correct on 2 of the remaining parts. Or you can get a 1, minimal response, by getting an essentially correct on 1 or 2 of the 5 parts, or partially correct responses on both B and C. So that's it for this question, and thank you for watching.